an exported function from stringer, and it says search for this fixed series of bytes, of character values, rather than a regular expression, which is handy for things like dots, right? So up here, I wanted regular expression power because I wanted to be able to match any number of dots. So I had to do this escape goofy double backslash thing. But if I just wanted to match literally a dot, I can do that with the fixed function to say search for the literal thing, a dot. Okay, what questions do you have so far about tibbles or stringer?
How far you can take been able to take nested tibbles?
Nested tibbles? Yeah, so tibbles support list columns. So you can put anything into a cell in a tibble, which I'll demonstrate a little bit later. So data frames or tibbles are awesome. They keep your observations together in a row. So if you have something more complicated that is attached to an observation, it's great to be able to keep that in a cell in a data frame, even if it's a big complex thing, rather than having a list that has the same number of elements as your data frame. Because you can then filter or rearrange the data frame and keep those more complex things in the same order in relation. So I'll show later, I do some modeling at the observation level, and I store those models in a cell. That's as much as I'll do here, and I honestly haven't used it much more than that, but you could conceivably have a tibble with a column that are tibbles, and inside each of those is a whole table, and inside each of those is a tibble, and you could think about relational data structures and how you could nest things like that and get a lot of power, but I haven't done too much with it.
Are there any mainstream packages that aren't, that don't play well with tibbles, right?
That's a great question, Mark. So the question was, are there any mainstream packages that don't play well with tibbles? One of the things that bugs me about tibbles is if I do row names of D equals whatever, sequence of length n row of D, I get this warning message that setting row names on a tibble is deprecated and soon will be defunct. So you can't set row names on a tibble. And there are lots of packages in R that use row names. And that makes me nervous. For right now, it's just a warning. But if they ever decide that you really can't set row names on a tibble, that's going to break functionality with a whole bunch of packages. You have a comment about that?
One other thing to keep in mind is that tibble is also an abstraction of a data object or a table object, which the dplyr or the dbplyr package is built off of, so that the same operations work on a remote data table that work on regular tibble or regular local data frames, which if you're using a tibble that's a remote table, does not work on. Some things don't work locally. Even some of the tidyverse doesn't work on remote stuff.
Yeah, that's a great point. So I suspect we'll be hearing more about that at next month's meetup. But so there's dplyr and there's dbplyr, which allows you to do dplyr-like stuff on a table in a database. So you can do joins and all sorts of stuff before you pull a table into memory, but not all of the functionality is available there when you're working on a remote table.
Something probably worth adding to what you said about the tibbles and row names is that the data frame underneath the tibble can still store the row names. It's just that the row names break anytime you do these tibble functions.
Yeah.
It's sort of long-term fix if you have a package that takes a data frame that requires row names as the column to row names. If you wrap your tibble in the column to row names function, that will be able to, it will still work as a regular data frame sort of feature package.
Yeah, so I'll demonstrate this row names to column function that he alluded to in a little bit, which is sort of Tibble's idea about what we should be doing with row names. But I think that the other broader point is that you can always do as data frame on your Tibble, and then you have a data frame that behaves as a data frame. So then I get the original data frame printing, and we can see why Tibble printing is nice when we do that. But you can always get your data frame back, right?
Sorry, the important point with that is if you do it this way, then you won't actually have those row names anymore. So you need some way of, if you've got a column that has your ID value, you need to convert that column to row names because the
Gotcha.
Or you can call in just one function inside of the package. So if you're
Yes. So
using ID for each observation.
yes, it's just putting that workload on the maintainer of the package to do that coercion. And if that package relies on another package, there's a whole chain of having to maintain that consistency. Yeah. Anything else at this juncture? Wow, 12:27 already. We should keep moving. Okay, Magrider is awesome. It gives us this pipe in R. It gives us a bunch of other pipes too. This is the only one that I'm going to demonstrate today. Pipes and other sort of infix operators. The pipe is super cool. It takes the thing on its left and passes it to the thing on the function on its right. By default, it puts the thing in the first argument position of the function on its right. So this is the same. This chunk of code here is exactly the same as this chunk of code here, right? This is saying names of D is the first argument to string replace all. Names of D is still the first argument to string replace all. I've not specified the first argument here. And then I take the output of this and pass that through to toLower. So it allows us to chain operations together in a way that is compatible with how we think, how we're developing this functionality, right? In base R, I could nest these functions, right? I could write toLower, string replace all, names of D, but then I have to think about it backwards to the way I want the functions to operate, and then the arguments to the function are getting detached from the function that they apply to. This is more intuitive, burn fewer CPU cycles in your head as you're writing the code, makes it easier to read. I like this. I like setting the thing that we're going to act on as the beginning, and then piping that into the first operation. You'll see I'm doing that here in ggplot. It helps you sort of see what we're starting with and then what we're doing to it. It also, setting the item, especially the data frame, out as the first row by itself gives you tab auto-completion in RStudio of the variable names in non-standard evaluation in the functions below. And if that didn't mean anything to you, don't worry about it. Okay, ggplot 2. I've highlighted this as a quote. It's just me saying that as a quote, but I firmly believe it, and I think probably most people would agree. If visualization isn't part of your exploratory data analysis process, you're doing it wrong. We are visual creatures. We find patterns through looking at data visually. It is an integral part of the exploration process, and ggplot, especially with these other packages in the tidyverse, makes that really convenient, easy, powerful, and gives us really good looking plots at the end of the day. So as a first example, let's say I want to look at, so there is actually a data set that we're looking at here. So this is the World Happiness Survey data from 2018. It comes from the Gallup World Poll, Gallup World Survey. And I'll just show you real quick. Glimpse is a function from Tibble, I think. It's like an improved version of structure for a data frame. So we've got at the country year level, so our level of observation in this data is the country year. We've got all sorts of variables aggregated to that level, right? So across individuals in Afghanistan in 2008, log GDP per capita is 7.16. This life ladder variable is sort of the primary outcome of interest. It's the text of the question is at the bottom of the notebook that I've put on GitHub, but it's imagine your life on a ladder with rungs numbering from 0 to 10, where 10 is your ideal life and 0 is your worst life. What rung of the ladder are you currently on? So it's a measure of sort of overall life satisfaction couched in this metaphor of a ladder. The closer that is to 10, the more satisfied folks in that country year are with their lives. So let's say we want to look at life expectancy for healthy kids at birth over time. Here is a ggplot to do that. We put year on the x-axis, our y variable on the y-axis, and we say we want to group by country, so we want a line per country And then we say we want to draw lines. We want to draw lines with 50% opacity. And then the year variable that I'm putting on the x-axis is a double in this tibble. So it prints with decimal points by default. So I tell it, put the breaks, put the line breaks every 2 years starting from 2006. And we see this increasing trend in healthy life expectancy, pretty much universal. There are a few downward sloping lines there, but we can see that it's almost universal that life expectancy is going up over this period in these countries. We could probably figure that out by running some models or running some summary statistics, but plotting it makes it really obvious, points to outliers, points to next steps. Okay, cool, but let's demonstrate a little bit more power. What if we wanted to look at not just this one question, but all of the questions? How do all of these questions change over time? I do a little trick here. So the gather function, I'll walk through how this works just below in the notebook, but it melts a data frame. If you're familiar with the reshape or reshape2 packages, it takes a wide data frame and makes it long. The idea there is to make data frames tidy. Here I'm using it in kind of a hacky way to put each question on a separate row. So I'm going to have a column in the data frame that is the question, and a column in the data frame that's called value, that is the answer to the question. And I'm going to keep country and year as the identifiers. Then I'll talk about what this mutate line is doing in a second. And then, so I'm putting year on the x-axis still, and then I'm putting the value on the y-axis, and I'm faceting across question. So I want a separate plot, a separate panel for each question in the data set. And here is what that looks like. I tried not to spend too much time on the aesthetic quality and rather focus on demonstrating functionality. But so now we get, for all of these questions in the data set, we get the trends over time at the country level, which is pretty good for like 6, 7 lines of code. That's like a pretty good lens into this data set, how these variables are changing over time for pretty limited code. And so we could dive into that, see where there are patterns of interest, which questions we want to investigate further. We can start positing relationships between the questions, et cetera, et cetera. Okay, so let's talk about that tidier gather function. I'll go ahead and copy this over here. So here's what our data looked like, right? We have tidy data. We have each variable, each question in a separate column. What this does is it says, take this data frame D, make an identifier column. The key, so key is an argument to gather. It's saying make a key column that is the question, and make a value column that is the value in there. So this question and value are names that I want to create. Right? They're names in the data frame that I'm creating. And then we choose which columns to gather over here. And here I'm saying gather everything except country and year. So I've said keep country and year. It's done that. And I've said create a new key column that is the question and a new value column that is the answers to the question. So that's what that looks like. And then we can take that and put that into ggplot in the way that we want. Okay, now forcats and dplyr. Forcats is a core tidyverse package that deals with factors, makes it easier to work with factors. Forcats is a anagram. Thankfully, we have a text expert in the audience. It's an anagram of factors. There's a rearrangement of the letters in factors. It's a handy package to make working with factors easier. All stuff that you could do in base R just makes it easier. One of the things that I use forcats for a lot is to order the levels of factors. Right? I want them in a certain order in my plot. There are a bunch of functions to help us do that. One of them is factor in order. So factor in order, like stringer, so all the stringer functions start with str underscore. All of the forcats functions start with fct underscore. In order says take the order that the levels appear in the data frame and make that the order of the levels. dplyr has an arrange function that helps you arrange rows in a data frame. Those two functions together are super handy, right? So you can arrange rows in whatever order you want and then use the order that the factor levels appear in to set the factor levels. Pull is a function from dplyr. It says pull this vector out of this data frame. So here I'm running that tidier operation to melt the data frame. Then I'm pulling out the question vector. I'm saying set the factor levels in order that they appear in the data frame, and then tell me what the levels of the factor are. And we see that they come out in order that the columns were in the original data frame, which then when I plot them in ggplot, those are maintained. If I didn't do that, they would show up alphabetically. We'll look at some other ways to order factors in a minute. dplyr, it seems like most folks here are familiar with dplyr. I think most folks who use R at this point are familiar with dplyr. It's awesome. It has a whole bunch of functions. I won't get into most of them because there are just a ton. But mutate is super handy. I'm saying create a new column, new variable called question. Here I happen to be overwriting an old column called question, which is the old question with the factor levels in order. Here's another thing that dplyr can do. It can summarize. So base R, you could summarize with aggregate or tapply. Summarize makes it easier. dplyr makes it easier, and it keeps things in a data frame-centric worldview and keeps everything tidy. So here, I'm saying take this data frame, group it by country, and then calculate all of these functions at the country level. So I'm summarizing the mean GDP. So for each country, over the years that we have for each country, calculate the mean GDP, calculate the standard deviation of the GDP. And then one neat thing about dplyr functions, and tidyverse in general, is that they evaluate lazily, but they will evaluate, what's the word for this? They'll evaluate on the spot if you need them. What is it? Linearly. There's a word for it, but anyway, I just created standard deviation GDP, and I can use that in the same function call. Right? So that's nice.
One pitfall on that, don't do that on remote data frames, it won't work.
Don't do that on remote data frames using dbplyr, it won't work. Good to know. And then another dplyr function is arrange, so I'm saying sort the rows then in descending order of relative variation of GDP. And we see that China has the most variance in GDP over this time period, which is not super surprising, right? They've developed rapidly over this period, so there's a lot of variance in their per capita income over this time period. Now, let's shift back to ggplot to take a visual look at the same phenomenon. At this point, I was just like, what other stuff can I demo in the tidyverse? And probably went a little bit nuts with it for this plot. So I'm doing a similar sort of thing. Oh, this is functionality that I really wanted to demonstrate. So group by summarize collapses rows, right? So when we say group by country and then summarize, we're going to get one row back for each country. If we do group by and then mutate, it will do the operations at that grouped level. So it'll calculate the functions at the country level, but it won't aggregate rows. Instead, it will append those values at the country level to every row for that country. So it's doing a self-join. It's doing the aggregation and then expanding those rows out and joining that expanded data frame on. Super handy. So group by country, calculate the number of observations. So how many distinct, that's probably not really the right function to use there. Calculate the number of observations we have for income at the country level. And then I'm calculating this affect score. So this is the average difference in positive affect versus negative affect for each country. And then rather than rolling that up to the country level, put those on as a new column on the original data frame. So we'll get repeated entries for each country. Then filter to where we have at least 2 observations for each country. Then the select function from dplyr to get rid of that new column that we just created. So I create it, filter on it, and then get rid of it. And then I wanted to demonstrate a little bit more ggplot functionality. So here I'm using the forcats function reorder to set the order of my x variable, which actually ends up on the vertical axis eventually over here. So I'm saying set the order of the countries by log GDP per capita, and the function that I want to apply to log GDP per capita, because we have multiple log GDP per capita observations for each country. So I'm saying use the 75th percentile of log GDP per capita at the country level to set the order of the x variable. So in this box plot, we see that we get the order of the countries in order of the upper inner quartile region for each country, right? So that's the 75th percentile at the country level. And so that's the order that I set for that factor level. And then I do some other things just to show some ggplot functionality, shrink the size of the outliers. I use this chord flip a lot, so that puts the x-axis on the vertical and the y-axis on the horizontal. Really useful when you have text as your independent variable, right? Text variables on the x-axis are bad. So this chord flip is really useful for that. For the labels on the y-axis, ggplot makes this really easy, right? So I want to take those income values that were on a log scale, go ahead and exponentiate them, put a $sign on them. I can do that right in this ggplot call without manipulating the original data frame.
Do you know about scales dollar format? Okay.
Yeah, so scales dollar format, it won't exponentiate. But yeah, so there's a scales package that does a lot of that formatting for you. So if you want to round or attach a $sign or use some other currency, the scales package will do that for you right in the middle of your ggplot call. The Viridis package is another, it's not in the tidyverse, it's an add-on, but it has ggplot color scales that are universally, so they're appreciable by all forms of color blindness. They print well in black and white, and they are perceptually consistent across scales. They are hands down the best color scales to use in R for any continuous variable. They are what you should be using. So what have I colored by here? Oh, that affect score. So the more yellow these boxes, the greater the positive affect in the country relative to the negative affect. And so I wanted to see, does that correlate with income or with the spread of income over this time period? And it looks like it kind of does. We see generally more yellow-green in these high-income countries and more green, purple, blue in the low-income countries. 12:45. Okay, I'm gonna zoom pretty quickly through some of this other stuff. You can look at the notebook if you want the details and how the code works, but I want to leave some time for questions. So here, so I was like, oh yeah, I did this, and I was like, hey, look, all those affect scores are positive. So those affect scores are mean positive affect minus mean negative affect, which is positive across the board here, or it looks that way at least, which is interesting. So negative affect is not stronger in any country over this time period than positive affect. So it's like, that's weird. I want to look into that. And that's the exploratory data analysis process, right? That looks weird. What's going on there? So I do the same. So I'm using that same. Oh, no, I'm not rolling up. Now I'm looking at the country year level, plotting negative affect on the x-axis, positive on the y-axis. I use this geom AB line to draw the one-to-one line, which in this case I'm drawing with a -1 slope because I expect high positive affect to be associated with low negative affect. Chord fixed to fix a square plot with a 1-to-1 ratio. And then I use this ggplot add-on package ggextra, the function ggmarginal, to add these marginal density curves to each variable. And now we can see what's going on there. So folks for negative affect, folks generally score less than 0.5, and for positive affect, folks, by folks I mean countries, generally score above 0.5. So there's just some human bias there to answering positive affect questions more generously than negative affect questions. But indeed, they do seem strongly negatively correlated. It's not like folks just have more affect or just like more arousable and so have greater positive and negative affect. They tend to move inversely. All right, this is a goofy example. I'm going to skip right over it, but you can make a correlation, plot a correlation matrix using tidyverse. Dplyr joins are super handy. Every time I show this to analysts at Health Catalyst, they're like, oh, I can do that SQL stuff in R? That's awesome. So here I'm going to pull in another sheet from that Excel workbook that has the region of each country and join that on to our original data frame. So from this read Excel function, Excel sheets tells us which sheets we have, what are the names of the sheets in the Excel file. I use that then with read Excel to pull in this supporting factors sheet. And that has these regions. I use select from dplyr to rename region space indicator to region and just keep the region in the country. I don't want whatever else was in that sheet. So here's what my region data frame looks like. Count is another handy function that I just wanted to demo real quick. So count data frame region, data frame reg variable region gives us the number of entries for each region in the data frame. Sort equals true brings the highest values to the top. So we see that we have 39 countries in sub-Saharan Africa, 22 in Latin America. I feel like a broken record. There are other ways to do that, but it's easy and that counts. Oh, right, I did this and I was like, North America and ANZ, what on earth is that? Maybe there are geographers in the crowd who were like, oh yeah, ANZ. I was not like that. So I was like, okay, let's look at this data frame at what ANZ is. So just to be a little bit fancy and demonstrate another stringer function, I say filter's a dplyr function, filter reg to where we detect the string ANZ in the region. And it turns out it is Australia and New Zealand. So they've grouped, right? US, Canada, Australia, and New Zealand as one region in this data set. Maybe it makes sense politically, not so much geographically. And then here's the join. So easy as this. Left join D to region. dplyr says, okay, I see one common column name between those tables, so I'll join on that. If you wanted to say join on country to country name, you can specify by country equal country name. But by default, it'll look for common names and join on that. And then, and then I'm rearranging the column order. So select in dplyr chooses columns to keep. Here I'm saying keep country, keep region, and then keep everything else. So I'm ordering the columns. By default, region comes in from that new data frame, so it's going to be all the way over on the right. I'm saying I want country as the first column, then region, and then everything else. And so we get country, region, and then all of the other variables. All right. More exploratory data analysis. I'm using the summarizeat function here. So a lot of these dplyr functions come with at, all, and if versions, so we can choose which variables we want to manipulate. And here I'm saying summarize at variables, summarize at all variables except for those that have year in the data frame, in the name. So I'm saying exclude year, all the other variables, calculate the mean value, and ignore NAs. And then I plot this outcome variable life ladder against log income and facet by region to see how life satisfaction varies with income across regions. I was looking at this and wondering what these NA countries were. What are these countries that don't have a region? Right? So this is like common exploratory data analysis stuff. Not super sexy, but it is important, right? You see missing values. What do those represent? Is that missing at random? Does that indicate some variable that's actually important? So I wonder about that. I would get at it this way. take D, filter to where region is missing, and then give me the distinct values of country. And we see, I have never heard of this country before. I will confess to my geographic ignorance. Does anyone know what Comoros is? It's off of Africa. It's a regionless country in this data set. Cuba, for whatever reason, doesn't have a... Some of these are weird, right? Oman, Swaziland, some of these certainly should have regions. I will really zoom through this. Maybe more than any of the other stuff, does stuff that you could do in base R, but does it more safely or does it better. So it has lapply and sapply or vapply-like functions that specify the outcome type. So map is like lapply or sapply. And here I'm saying I expect a logical outcome for each entry that we get back. And that means that I will get a logical vector back every time. So in programming, that's really useful, right? I know that I'm going to get a logical vector back from this, or I'm going to get an error. So map logical over D, is the column numeric? Yes, it is. Cool. It comes with this. So here I'm saying I expect a double back. I expect a number back for each entry. This handy syntax tilde allows us to use .x or dot for each entry in this. So I'm calling each column in D .x here. Give me the count of NA values in each column. And I get back a numeric vector. I love mapdf. If any of you used the plier package or use the plier package, it was great. It had a lot of flexibility for what you put in and what you get out. It was horribly slow. Mapdf is faster, and it says, I want to lapply over these things, and I'm going to get a data frame back for each outcome, and then I'm going to row bind those data frames together. So here it's a silly example, but I'm lapplying over 1 to 5 and saying create a data frame for each entry where we have the value, the square of the value, and the letter indexed by the value. And we get back a 5-row data frame with those entries.
So it returns, even though you're specifying a data frame, it's returning a tibble?
It's returning a tibble data frame, yes. Yep. It also has a multiple apply function, and it has multiple apply to these various kinds of outcomes. So map2 says, I want to give you 2 inputs, and I want you to apply over them in parallel. So here I'm giving it these 2 vectors, James, Jill, Joe, and 9, 12, 7, and saying do this function, paste those things together, where the first thing, the names, gets referred to as .x, the second thing gets referred to as .y, and I expect a character vector back, a character entry back for each thing, a length 1 character vector for each thing. We'll put those together into a character vector, and we get that. Flatten is better than unlist. It never recurses, and so if you want to recurse, if you want to flatten multiple levels, you call it multiple times, and it uses sensible names. I love this transpose list. Before I knew about this, or before PER came out, I was trying to transpose a set of nested lists independently in base R, and it was awful. It was really, really hard. Maybe you would find it easier. I found it really, really hard. Transpose turns a list inside out. So the original list had these outer lists called outer 1 and outer 2, and these inner lists, inner 1, inner 2, inner 1, inner 2. We often get like JSON data like this, right, where we have deeply nested lists. Transpose pulls them inside out. So now the outer list is inner 1 and inner 2, and then the inner ones are outer 2, outer 1, outer 2, outer 1, outer 2. It's cool. You can also, with the map functions, you can also index into lists recursively in a really neat way. So you can say, go into the first item and then the second item within that, and then find the thing called mileage within that and pull out that value, and you get a character vector of mileage out from that. Super handy. Safely is a tidyverse version of try or try catch, where you always get back a length 2 object with the result and the error, and one of them is always null. So it makes it easy to type, check that, and ask if result is not null, then use that. And then I do some more exploration, which I was kind of excited about, but maybe I'll leave that to explore on your own if you're interested, and instead use the last 5 minutes for questions, comments, or concerns. You can do so many cool things with the tidyverse. I'll leave with this. So this is a plot of Oh, right, so I didn't get to the nested Tibbles thing. So what I'm doing here is fitting a model. So I'm using this do function from dplyr to fit 2 linear models for each country. So I'm looking at the change in life ladder and satisfaction over time and the change in GDP over time. Not a good statistical idea, right? Not advocating this as good statistical practice, just demoing this functionality. So I'm fitting a model within each region at the country level, fitting both of these models. Then I pull out the coefficient for year, the beta value for year from both of those models, and then I'm back in a data frame. So I have put these models into a column in the data frame, pulled the beta coefficient out of that, and then I have a numeric column with those betas, and then I can go from that straight into ggplot, right? So in this pipeline of calls, staying within this one data frame, staying nice and organized, and I end up with this ggplot of the estimate of change in GDP over time against the estimate of change in life satisfaction over time plotted against each other. And so we see that the countries that have the most rapid improvement in income, the most rapid gain in income, have the most rapid gain in life satisfaction over this period. And I've left the countries in there as text so that we could, this is exploratory, so we can say, oh, look at that. Syria and South Sudan are these major outliers. I wonder what's going on there. Right? It's a little bit easier than if we had plotted these as points, and then we'd have to figure out, okay, filter to where beta is less than 0.4. Just makes things a little bit easier. Okay, and then there's more, but I don't have time. So, thank you for your attention. Do you have any questions?
So I noticed that you didn't use Broome in there. Was that just for extra time, or in the when you fit the models and then got?
I did right here at the end, Julia. I just didn't get there. So Broome is super cool for a few things. So Broome will take any model object and turn basically its summary into a data frame. So you get, for the model, you get the intercept, the coefficients in columns, and then the sum of squared residuals and whatever else. Super handy. It takes all kinds of different model objects, whatever fancy modeling package you use. It's very likely that Broome handles it. And especially when you're fitting multiple models, it makes it really easy to work with them.
It's not just models, but you give it a named vector and it'll turn that vector into a data frame with names and values. You give it a data frame that has row names, and it'll turn the row names into a column in the data frame. Basically, Broome is clean up anything that you give to it and give back to it.
Yep. The other thing I blew right through and didn't have time to mention was row names to columns. So this used to be, maybe still is, a function in Broome. It's also now a function in Tibble. But row names to columns, take the row names of your data frame and make them a column in your data frame with the name that you specify here. There's a function like that in Broome and this function in Tibble. Other comments or questions? All right, if any come up, or if you look at this code and you're wondering why something works the way it does, or you try to adapt it and it's not working for you, please feel free to get in touch with me. I think my email is at the top of this document. I'm sure you can find other ways to get a hold of me as well. But thanks for your attention, you guys.